My talk is about nonlinear quantum physics to Eurhythmic physics. Eurhythmic physics is a proposition for a global vision that I feel, or anymore, that here this conference is a kind of emerging idea in this among us. The introduction I start with the quantum theories, of course, the nonlinear approach for understanding quantum reality, as we know, was proposed by Niels Bohr in the Vigier Conference of 1970, and it was accepted practically by all the scientific community. Still, as is well known, many thinkers, for which you can point out Broglie, Einstein, Faraday, and many others, always objected to the view of the world proposed by orthodox quantum physics, that is, by Niels Bohr. Still, only the important work of David Bohr and Jean-Pierre Vigier in the 50s, the true recovery of causality would take place. The School of Lisbon, initiated by Ana Silva, a disciple of de Broglie, was able to devise the first experiments that could answer the important question of quantum physics about the true nature of quantum waves. The problem is, are quantum waves physical reality, or on the contrary, they are mere probability waves, thus devoid of any physical reality, as is claimed by orthodox quantum view. A recent experiments done in Germany tell us that quantum waves do have, in fact, physical reality. Furthermore, it was shown, first theoretically, after experimentally, that it is possible to go much beyond the limits imposed by Heisenberg relations. These works culminated in the publication of this enlightening book. A popularizing version of that book, in a kind of the house for everybody, is in sequence of these efforts and following the Broglie research program, always with the idea of the Broglie initial ideas, it was possible to arrive or to propose a more general field theory that includes not only nonlinear quantum physics, but also all physics. And this is called Eurhythmic physics or IPL physics, the unification of physics. That is was published last year in that. Let us now briefly was the essence of traditional physics. Traditional physics was founded on the Cartesian linear method, where the whole is assumed to be the sum of the constituent parts. These parts mix without any modification, and consequently the action is proportional to the reaction. The Eurhythmic approach to understand action assumes the basic inner, even at the very basics of the reality, the complexity of the physical entities. And consequently assumes, as I understood most people here agrees, that the whole is in general much more than the simple linear combination of the constituent parts. And that a small action may, under certain given circumstances, give rise to a huge reaction. As a consequence of the fact that the parts that make the whole, when they mix due to the reciprocal interaction, change themselves. So the properties of the new being that emerge cannot, in general, be different inferring from the properties of the constituent parts. Still, this does not mean that the linear approach is wrong. The linear approach is a very good approach. When the parts mix and that interaction can be neglected, for instance, when I walk in this floor, I change the floor. Change the floor. If you look at a monument in Italy, is full of movement. You look at the stairs, they are very warm, because each people changes a bit. But this changing is so small that can be neglected for most practical circumstances. So the Cartesian approach is a good approach, of course, but at the scale of application. If you want to go further, you need to take into account that things change. That is when the change can be neglected during an approach and pushed to be adequate. At the beginning of the 20th century, there occurred, as everybody knows, a great improvement in the making of experimental devices. These fantastic devices allowed the problem of knowledge at very short scales, both in time and in space. With the help of the interferometer, it's possible to estimate different times, about 1/10 of a second. I believe you know that Galileo, when intended to see if the velocity of the light was finite or infinite, used it as a clock, the pulsation. How could it decide and it changing the velocity of the light with that precision? But with this precision, these things become possible. With spectroscopy, a new window of nature at very short scales was possible. That is, it's possible to study at microphysical level. In these conditions, experimental evidence coming from diverse origins in the field of great velocities and now microscale of observation clearly shows that the traditional Cartesian method, where the wall is equal to the sum of the parts, was not adequate, I don't say wrong, not adequate to deal with these discoveries. Still, the researchers of those times, full formatted in the Cartesian way of thinking, tried at all costs, of course it's natural, to interpret the new complex non-linear phenomena in the traditional linear framework. From this giant effort, relativity and quantum mechanics were born. Now that we have the advantage of being more distant in time, we may have a clear vision of what the physics of the 20th century really was. A brute force attempt to linearize essential nonlinear complex phenomena. These facts led us to the conclusion that it is necessary to develop a better approach to understand nature, that is, physics. This new global complex nonlinear process will naturally lead to a true unification of physics. The unified global physics, Eurhythmic physics, or hyperphysics, will assume as a basic starting point that the phenomena we want to describe both at the quantum scale and at the domain of great velocities need an interval rationale where you cannot distinguish between the observer and the being parties observed. We need an interrational nonlinear process that requires an integrated complex nonlinear approach based on the principle of Eurhythmic. We shall discuss the principle of Eurhythmic with more detail later. As I said, these facts in any way belittle the great merits of the Cartesian method and consequently of traditional physics. Indeed, the Cartesian method was one of the greatest achievements of humankind, allowing the scientific revolution. Nevertheless, and this is a very important point, theories are human constructs. So, it's no surprise to verify that in this case, this useful and simple process of inquiry nature has its inherent limits that at the end of 19th century started to appear recurrent. Now, in order to go further, to progress in the understanding of natural phenomena, that is of physics, it is necessary from the very beginning to adopt a non-linear complex way of thinking. At the same time, we need to keep in mind dar acte statistical variantes sobre intrinsical non-linear problems main equated the approach using the more simple linear Cartesian framework. Let us see the basics, very difficult of course, of non-linear quantum physics. Non-linear quantum physics, as I told, was inspiring the works of the world. Was the first thinker who dared to present a non-linear approach for solving the mystery raised by quantum wave theory. Because he proposed that the guiding wave, practically without energy, could guide a very large energetic entity. Here we present a sketch, as I saw, of non-linear quantum physics block and visualization problem. In this approach, the intrinsic complex nature of quantum phenomena is assumed ad initio. Still, as I told, whenever the Cartesian linear approach can be applied to recover quantum mechanics, orthodox quantum mechanics at predicting level. The interpretation is different. There are new kinds of predictions, but everything predicted by tensor quantum mechanics is predicted also by this nonlinear quantum physics. This is the idea for the Broglie for the quantum particle. For Broglie, a quantum particle only the Broglie stated only for quantum particles. Now we have generalized for all physical entities. Are very complex entities, even the photon. They are composed of an extended, a kind of sensorium, a wave, very extended, and inside of it there is a very localized structure, initially called it singularity, and now we call it atom, inspired in the acropolis from the Greek dipolis. And the theta wave, that is now under many names, empty waves, guiding waves, and other names. And this wave guides through a nonlinear process, because the energy of the theta wave is very small. The atom, or kernel, is the entity of the particle, or the part of the particle that contains the energy you can really take. You cannot see directly theta waves. This is a complex particle is a function of the extended wave, a kind of sensorium, and the kernel. The Broglie made this approach, the linear approach, saying that the particle is the sum, the linear composition of the wave plus the singularity or kernel or atom. For many situations, this formula works well. Now, the rate of the energy of the kernel and the theta wave is about of that figure. This is an estimation. If you are interested, you can look at that paper. The most important assumption is of nonlinear is the principle of Eurhythmic, which states that background that is immersed in the theta wave field, the guiding wave, the sensorium of the particle, follows a stochastic path that leads the particle to the regions where the intensity of the field is higher. This principle was introduced by Broglie at the beginning of the 20th century to describe quantum phenomena in order to explain the Helsinki experiment, and is appears in nonlinearity. The Broglie initially called it the guiding principle. That we shall discuss and return to the Eurhythmic principle. It is possible to, in this nonlinear quantum to derive a master nonlinear equation. The master nonlinear equation comes from this to form conservation equation for particles and for fluids. Doing the additional relations, it is possible to arrive at the master nonlinear equation. This equation was presented also by Vigier with a coefficient different from 1. It was derived in another way. When this term, this nonlinear integral, is constant or null, you are in the realm of Schrödinger equation. The particular case. Let us now look here briefly what is nonlinear quantum physics. In nonlinear quantum physics, we treat at the same time both the extended part of the part and the kernel that carries the energy. So these two entities, not separate but for talking, we say corpuscle and wave are treated as a single complex entity that cannot be separated. And with this, we have to the Newton-Jacobi equation for parts and the continuity equation. It is as a law entity. When you split, you say it is possible at this level of description of relative theory de corpuscular aspect and relator espaço independent entity. It's correct. It's not necessary, as when I wrote this form, it's not necessary for what I am doing to see the microscopic change of this flow. So, this approach, I split this nonlinear mass and this solution is, we try to take this as two independent entities. So, for nonlinear quantum physics, I arrive at classical physics, splitting, treated as independent entities, the localized properties of the physical entities from the extended properties. Inversely, if I can start from classical physics, where I treat particles and waves as independent, now it is necessary to fuse in a single entity these two properties of the quantum entity. I arrive at nonlinear quantum physics. Let us now see a very important point that has been neglected, and I believe that is because of the misunderstanding of Fourier and Broglie. Einstein and many people never were able to go, were always, when we discussed with Broglie, with Niels Bohr and other people of the orthodox quantum mechanics, lose almost all discussions. It's because of this idea. As you know, the most important physical forms of quantum physics are the Broglie relation and Planck relation. This relation meant with the spatial frequency and the energy with temporal frequency. Now, yes, but frequency of what? The answer, of course, is frequency of wave. But what kind of wave? What kind of wave has a pure single frequency at delta K, delta omega equal to 0? What kind of wave? Here is the point. The answer depends on the theory. Let us see the answer of Niels Bohr. The answer on this Niels Bohr is this. Is in fact in the sixth Eden postulate of quantum mechanics. The only waves that have a single pure frequency are the harmonic plane waves, which, as we know, are infinite in time and space. These waves. That is, the Fourier waves are only present in space and time. And now I ask, is there any physical wave that is omnipresent in space and time, at least the ones that we observe? So, the conclusion is that real physical waves are always fine. Fine. No real physical wave is infinite. It's an approximation, of course, and certain principles work very well. This solution is called Fourier, which was developed by Niels Bohr in his summer vacations of 1927. He developed this idea, and From this idea, from Fourier analysis and connecting with the fundamental relations, he arrived at this formula which you now are Heisenberg relations. He presented these ideas for the first time in Italy in the Lago di Como in the Vigier Conference in 1907. And they can go to the Soviet Conference. From these relations for equality, we have the red line. The red line. For the inequality, we have this. This is the space, the Heisenberg measurement space. This is the forbidden region. According to this interpretation, the human mind has no possibilities of going in this region. That is, it cannot predict the results of a future measurement of the position or the momentum or a pair of conjugate variables that fall in this range. The state detectors now try to look at the concept of natural frequency. What do we understand by frequency? Intuitively, complex of frequency corresponds to the rate that a given pattern, for instance these chairs, are localized in space or in time. I am meeting here and this distribution. If we are dealing with the real physical things, this pattern starts at a moment or at a position and ends after. It's always finite. So the concept of natural frequency is this, is the rate of the repetition that a certain in time, in a certain given pattern of measurement is distributed. Now let us see a finite wave, a real physical wave is finite. It may have a simple frequency, k or omega, such that the k delta equal to 0. This one of the first is the Morley-Gaussian wavelength. This concept of wavelengths, the story starts very early, but for all practical purposes, it started with Jean Morley in the late 80s. He was an engineer that worked in oil inspection. For the technical, the oil in the soil, they used the Fourier analysis to study precision science. And this is, but Fourier analysis is no good to treat this kind of science, and he invented this analysis. So here we have a Morley-Gaussian wavelength, a finite wave that has a single plural frequency, in this case a temporal, a special frequency. From this wavelength analysis, following a process equal to one of the Niels Bohr, it is possible to arrive at this more general uncertainty relations. The difference lies in this thing. This is the size of the wavelength, of the finite wave. If you can see, if this wavelength is very big indeed, this same terms practically zero, and you arrive at general, at the Heisenberg uncertainty relation. That is, the general uncertainty relations contain, as a, from a formal point of view, as a particular case, Heisenberg relations. Here we have a plot for the sigma very big, this red line equal to line is very good, for different values of sigma. That's it. All this space, the forbidden space, becomes now available. Let us now see what the experiments say about this. Is it possible to make measurements, make predictions for measurements, where you can go, where you can predict the error of the momentum and the position of a microparticle that goes in the forbidden region or not? The answer, of course, cannot be given by nature, by practice. Let us see what nature tells us. Very good. The traditional experiment posted in almost every textbook of quantum mechanics for uncertain relations. We have here a microparticle, and upon it, quantum of light impinges, upon interaction with the microparticle, transfers a certain amount of momentum, and later is collected, is diffused, collected by the sensing probe of the device. The uncertainty in the momentum is given by this formula. You can see this formula in almost every textbook of quantum mechanics. Now, let us see the uncertainty in position. If you use a common microscope, a Fourier microscope, the microscope that exists at the time of Heisenberg and other people, you know that the maximum theoretical resolution for a common microscope is half of wavelength, lambda over 2. When you make the product of this by this, you write Heisenberg relations natural for the ideal situation. In general, it's much worse than this. So, Heisenberg relations. Now, we make the experiment instead, here is precisely the same, instead of doing this experiment with the common Fourier microscope, use a super microscope. For this called scanning near field optical microscope. For this microscope, the vertical resolution is lambda over 30. There are other microscopes with greater resolution. So, making this product, we arrive at the discrepancy in the Heisenberg equation of this value. That is, we are making measurements precisely in the forbidden regions. Of course, this does not mean that Heisenberg relations are wrong. They are good relations. What is wrong is implying that they are the last word. Heisenberg relations are very good for the problems treated at that scale. If you want to go beyond, you must change. Let us now see a brief Eurhythmic physics that is a natural extension of nonlinear quantum physics and is based on 5 basic assumptions. The first assumption that we have, I guess, here people is that there is an objective reality. And a very important point. This reality is observer independent, but the observer interacts with the reality, changes the reality, and at the same time is changed by it in greater or lesser degree. That is a total interdependence, not independence, but interdependence. The second assumption is the subquantum medium. There is a natural infinite chaotic medium named subquantum medium. It was proposed by Broglie, by David Bohm, by Jean-Pierre Vigier, and many other people. Now, all physical processes do occur as emergencies of this natural medium. By chaotic medium is understood a medium in which, in general, it is not possible to make predictions. The subquantum medium is in some way alike to the theorem of Anaximandro. The infinite medium, the subquantum medium, in this sense, are the true real being, the what that exists by itself. The third assumption, the third and fourth assumption are related with the definition of physical structure and particles. What are named physical entities as particles, fields, and so on, are more or less stable, organized states of the basic chaotic subquantum medium. The fourth assumption is the quantum definition of the complex particle. In general, a complex particle, the complex physical entities, the particles, are very complex, relatively stable, organized states of the subquantum medium. They are composed of understanding of interrelation, so and so on. The fifth assumption is the principle of Eurhythmic. This is the basic principle. This is the maestro of the orchestra, of the physicists. This basic organizing allows the making of mathematical conditions. It states that diagram moves chaotically in the theta wave field following a stochastic path that in a direction leads it to the regions where the field has greater intensity. The principle of Eurhythmic comes from the name Eurhythmic, which is the composition of the roots Eu plus rhythmic, Eu standing for the right, the good, the weight, and the rhythmic for the way, the path, the harmonic motion. The composite what meaning? May mean the great path, the good way, the right way, the golden path, and so many possible names. Meaning always same is the principle of persistence. Any complex entity tries to persist, and if in order to persist, you need to choose the best way, best for its survival, of course, in interaction with the medium. Let us now see how in physics we understand the graphitic field and the graphitic interaction. Maybe I leave this, if I have only 5 minutes. It's the why of the why we know how a stone falls on the ground, but why this happens? What is behind this phenomenon? Many people try to explain it as, since I have no time to explain, I go on. They try to explain this phenomenon. One of the most important explanations was proposed by Georges Louis Lesage. He said that the world was filled of ultra-mundane purposes, so that the graphitic board was pushed by that ultra-mundane purposes from here, from that, so that all pushing action of the body needed to be still. Still, if we have two parties, each making shield to each other, it is possible in this case that they can approach with a law that is given by one or S. The theory of Lesage will a certain amount of success in the late 19th century. Then, with the development of statistical physics, it was shown that this theory had problems related to the principle of conservation of imaginaries. That is a linear theory. There were made many attempts in the second half of the 20th century to recover Lesage pushing theory using either waves or corpuscles. Nonetheless, all those attempts had problems with the energy conservation principle. In reality, none of those verifiable theories based in the classical principle of equality between action and the reaction worked well. To make things even worse, all those adopt theories lacked non-logical approach for understanding physics. Let us see the concept of interaction in non-Eurhythmic physics. Here we have a complex part, here we have the acron, and supposing that the field, the theta wave field, has a radial symmetry, that goes in this direction, or there, he has in a random motion, but the average motion of the acron is still in a average, does not move. Still, if we have two particles occupying the same space, the density, the intensity of the field here is greater than here and here. So they have a propensity to approach. Here we have a similar-dimensional, a single part, the diagram is here, using every direction, but the average position is here. And can say that it's steel. Not steel, of course, but in a very steel. If we have two particles, two fields, here in case of Eurhythmic, so there is a liquid here. So this here. So this is the conscience theorem, was numerically simulated by Professor Marigata, one of our collaborators of this concept. It is possible to show that not very far from the origin, not very far away, this interactive process may be described by a law equal to Newton's law for attraction. The repulsion of repulsive force happens when the two waves, by a kind of self-organizing process, overlap here in phase of position. In this case, there appears here a dip. In this case, the parties, the atoms, tend to go apart themselves. How many times? How many? 3 minutes. I have no time for this to finish. And to explain why the velocity of the light is constant in certain cases. I have no time. Have time for this?
2 minutes. Okay, anybody has some questions?
Kepler never made any connection between his light and gravity. He did not make such a connection. He never made such a connection. It was pointed out later that he could have done so, but he didn't make that connection. He had a law of light intensity, but he never made any connection between that and gravity.
Yes.
I think you need to correct that. It was pointed out that he could have done so.
There is a book.
There's no book that I know of from any reputable historian which says that.
Just wait. There is a book only on the attraction.
That is incorrect.
They say, I know.
It's incorrect. There is no evidence whatsoever that Kepler did that.
But there is a simulative when they look at that.
Oh yes, he could have done so,
Yes,
but he didn't.
Yes.
And it was pointed out that he
Yes,
could
yes,
have done so. So I think you should correct that.
Well, last comment.
Okay, at the very beginning you mentioned that there was an experiment in Germany that proved that the matter waves were physically real. And I just wondered, can you give me a reference or what experiment?
Yes. I can see the references. And two years ago, they used a nonlinear crystal. It is based in ghost imaging technology. Ghost imaging technology. The principle of the experiment is more or less like this. If you have one photon here, you know where the other is, completely independent. You have a picture here. The photons pass through the picture, and you collect the information. And in one there is no picture, and you collect all detection. Now you say, every detection here that has some here, you accept. All others that have no connection here, are not coherent in time. They are discarded. In this case, an image of this appears here. Because of it, they call it ghost imaging. So if you know a photon is here, the other is there.
Something to do with weak measurement, I think.
Like ghost imaging?
Ghost imaging.
Okay, well, maybe it proves
We
that
have discussed it,
somebody,
but I
I'll
think
have to check it out.
yes.
Okay, about 45 minutes before the banquet, straight past the lunch coffee outside the restaurant, a little farther against the wall, that's our area. Thank you, Jose. Molto grazie.